3.9 reads, if a woman takes an early pregnancy test, she will either test positive, meaning that she is pregnant, or test negative, meaning that the test says she is not pregnant. Suppose that a woman is pregnant. There is a 98% chance that she will test positive. Also suppose that if a woman is not pregnant, there is a 99% chance that she will test negative. Okay, so I'm going to create a probability tree. And I'm not going to write the numbers down yet, but the possibilities are a woman could be pregnant or not pregnant. Okay, and this is the reality. Okay, but if she's truly pregnant, then she can take a test, and if she is pregnant, then there's a 98% chance, 0.98, that the test will be positive, which means that even though she's pregnant, there's also a 2% chance that the test is negative. If she's not pregnant, the test can tell her that she is not pregnant, and the probability of that is 0.99. But even though she's not pregnant, the test could give a false reading of a 1% chance to actually test positive. Okay. Part A says, suppose that 1,000 women take an early pregnancy test and that 100 of them truly are pregnant. So in this case, 10% of our women, or 100 out of 1,000, are pregnant, which means 90% are not pregnant. It then asks, what is the probability that a randomly chosen woman from this group will test positive? So we're not asking for how many are truly pregnant, we're asking for those who test positive, which will be this group of women and this group of women. Those who test positive is equal to everybody who tests positive. There's two groups. There's really truly pregnant women, pregnant and test positive, plus those who aren't pregnant, okay, but they still test positive. So those who are pregnant and test positive, that is going to be the 10% who are pregnant times the 98% chance of testing positive if you're pregnant, plus those who aren't pregnant, 90% of women, plus times the 1% chance of still testing positive. Okay, this is going to be equal to 0.098 plus 0.009, and that is equal to 0.107. So about we have 0.107, so about 107 out of our 1,000 women will test positive. That's part A. Part B asks the same question, except that in this case, out of the 1,000 women, only 50 of them are truly pregnant. 50 of them are really pregnant. So the probabilities of testing positive and negative stay the same, except the probability of randomly selecting a pregnant woman or a not pregnant woman is different. Here, in this case, we only have 50, so 0.05, about 5%, and those who aren't pregnant will then be 0.95. Okay, so for part B, we still have the same question. We want to know how many are going to test positive, and that's going to be the women who are pregnant and truly test positive, plus those who aren't pregnant and still, because the test wasn't accurate, tested positive. So let me multiply that out. This equals 0.049 plus 0.0095. Here we have 0.0585. So this will be the probability of randomly selecting a woman who will test positive. Okay, that's the end of 3.9.